Hello, everyone, and welcome for joining us. We're just going to wait for everyone to come through. And I can see the attendees coming through, so that's great. Just give it a minute. Right, I'm going to get started. Hello, everyone. Welcome for joining us. My name is Anna Maria Faust. I have the content for Reed Mining Events, and I'll be supporting today's presenter. This webinar is brought to you by Reed Exhibition's mining portfolio of events comprising of AMEX, QME, and WA Mining. This is the first, or this is actually the fifth of an ongoing series of webinars where we present both live and pre-recorded sessions on a broad range of topics. So this live session you'll be able to see on demand later on our YouTube channel, Reed Mining Events. As this session's pre-recorded, we just ask that please leave the questions in the Q&A section down below. We'll be coming on later at the end to take those questions and answer them. So please use the Q&A box below if you've got any questions that you'd like to ask throughout the webinar series. I'm pleased to introduce today's speaker, Carlos Davenko. He's the application engineer for Northern Queensland and Northern Territory for Henkel Adhesive Technologies. Carlos holds a bachelor's degree in science with a major in chemistry. He has more than 13 years experience both in Brazil and Australia. Carlos has been with Henkel for 8 years and became an expert in surface engineering materials in industrial adhesives for the MRO industry. So I'll bring Carlos to the screen and we will start.
Thanks, Anna. So we are here today to talk about how to eliminate fasteners loosening and prevent failure in the MRO business in workshops and mine sites. Just a little bit about me, as Anna said before. So I have a bachelor in science with a major in chemistry, and I started with Henkel back in 2010 in the research and development area, moving to application engineer role over there, then end up moving to Australia and rejoined the company there. So in total, I've been with the business for 8 years. So starting our webinar here today, I want to talk to you first before what are the MRO or maintenance words that we have on the mine sites and in any workshop that LOCTITE can offer some solutions. The first one would be the reactive maintenance. So the reactive maintenance, it's something that it's broken and it need to be fixed straight away. So a pump is faulty, it's not working anymore, and then we need to keep that process running. We just need to run and do all the effort to get that equipment running back again. We also have the preventative one. The preventative one is the one where we expect that equipment will fail, and we do all the maintenance, so we make sure that that equipment keep running for as long as it can. The predictive one, it's the one where we know the time that equipment will fail. For example, if we have a pump and we know that the life extension of that pump is 1,000 hours, so we know that within 1,000 hours we need to schedule maintenance for that equipment. And we also have the proactive one. The proactive one is when we try to predict some failures that we might have with that equipment, and then we try to find solution. So all these areas, we have LOCTITE solutions that will help. If we look in the next slide, most of the failures that we have on site, especially in the mine site, it's 70% is just chronic failures. So which means that we would be talking about the preventative maintenance. So we know that those equipments will fail eventually. 30% only are problems that we have that they are accidents or we were not expecting. So these would be more the reactive maintenance, the side of the business. Accidents happen, equipments will fail without any reason sometimes, the unknown reason, better saying. But most of the impact, 70%, it's failures that we are expecting them to happen in the long-term run. So today we're going to be talking about some preventable downtime cases that we have in the industry. If you look at this slide, you can see all the areas where LOCTITE can help with our products and solutions. But today, just for a matter of time, we're going to be talking about only fasteners coming loose. So basically bolts and nuts. every single workshop, every single mine site, it's full of bolts and nuts and vibration. And we're going to understand why it's important to make sure that those bolts and nuts, they stay together in place. And if they come loose, what's the impact that might cause. So just so you guys can understand, if you can save 2% of your maintenance cost, that will impact direct on 75% of your gain in production. So if we can work more on the predictive side of the maintenance instead of the corrective side of the maintenance, that's a huge cost for the mine site or for your workshop line of production. So the main thing is we focus more in the predictive side, because that's when you know that you need to stop and you can schedule your maintenance. The corrective one, sometimes it's just a little bit sloppy. You just need to get things done quite quickly, and that's a huge cost for the business. So this slide here is just to show the impact of knowing your equipment and knowing how to do the preventive maintenance, how much money you can save at the end of the day. So what happens when fasteners fail? The next video that I'm going to play is just going to show you guys one application where they use the LOCTITE product to hold a bolt and nut together, and another application that they didn't use anything. They just put the bolt and nut together. It's going to be a little vibration, and you guys will see what will happen at the end of the video. Nice. So as you guys could see in this video, of course, it's an extreme situation. This is not something that happened every single day in a mine site. But the idea was just to show how come just a little vibration can get those bolts and nuts undone. And this could cause like a major issue in their process, or even a safety issue with something dropping on the head of someone that's just walking past. And that would be like even a big issue for this mine site or this workshop. Just showing a real case scenario that we have here. So here we can see a bolt size M36 in a massive structure, steel structure in a mine site that holds the conveyor belts. So what happened there? People just use these massive bolts and nuts and they torque it up to really high torque. And they thought that that would be enough to hold the structure in place. The problem is, especially where you have a conveyor belt or where you have most of the mine sites are in regional areas, you have a lot of vibration and you have a lot of temperature change. So with this temperature change, the material contracts and expands. You have the vibration moving the nut around the bolt there, as we could see in the video. And after 6 months, they could see that these bolts and nuts were coming undone, and this was completely damaging the structure. If you look at the bottom of the picture there, you can see a little bit of broken concrete there. So you imagine you have a conveyor belt on top of these, a lot of vibration, these bolts are coming undone. If they definitely come undone, that structure will just collapse, and that would cause a major issue for that site. Could be either towards safety or could be like just towards production, because if there's one area of the site that's not running, that's going to impact the whole process. So that's how important a bolt and nut is in the industry. I know that sometimes just for the size of the bolt and nut, we think that they're going to be fine because they are big and heavy, but we are talking about like really high vibration and temperature changes there. So you need to make sure that that bolts stay in the same place at all times. Before we start talking about the different ways that we can keep the bolts and nuts tied together, I like to talk about very simple about this one. Usually when we are using bolts and nuts, it's because we want to put two parts together. So to put two parts together, we need a clamp force. So what you do with the bolt and nut, you have the two parts of that sandwich there, you just put them together and then you add that clamp force and then they're gonna hold together. The reason that we do that and we don't bond them together, it's because eventually we're gonna have to get them undone for maintenance or for whatever reason it is, but that's why we use bolts and nuts. So we are basically getting two parts together through a clamp force. And what caused this clamp force to just loosen up a little bit and then gets these bolts and nuts undone? Usually it's vibration. So every site or every equipment, it will vibrate. Some equipments will vibrate like really high vibration that we can see. Some equipments, the vibration will be really slow. Sometimes we cannot even see with our eyes. But in the long-term run, you would be able to see that equipment vibrate a lot, and that could cause the bolts and nuts to come undone. Another factor is the thermal cycling. Thermal cycling, especially here in Australia, when you go to the mine sites, which are in regional areas, you can see that early in the morning will be 6 degrees, and then late in the afternoon, it's going to get up to 35 degrees, and then at night, it's going to get back to -2 degrees. So the temperature changes a lot. What happens with any metal is once the temperature is higher, the metal will expand. If the temperature is lower, the metal will contract. So this expansion and contraction at all times, this could cause the nut to start moving slightly, and again in the long-term run, that would get the bolt and nut would get undone. This is not something that you will be able to see it in 1 or 2 days. We are talking about 6 months to a year. So it's a micro movement that happens every single day, but at the end of the day, the little micro movements, they start getting bigger and bigger and bigger and bigger, and then they end up coming loose. Another problem that can cause the fasteners failing would be over tightening. So if you over tightening, you're causing a lot of friction between the metal. So you have metal grinding on metal there. Two problems can happen there. You're not going to be torquing up at the torque that is specified for you to torque, and also you could be damaging the threads. By damaging the threads, the bolt and nut, they won't be that perfect marriage anymore. They won't sit together in the proper place. What's going to happen is after a while with the thermal cycling and the vibration, that nut will just start moving slowly and it's going to come undone. So that's a big problem. Talking about friction in the next slide here, we can see all the things that can vary when we talk about friction. So one would be the surface. So it depends which material you're using. You're going to have a different coefficient of friction that we call. Also, the head or the nut diameter will change the friction of the system as well, and some clearance that you have. If you look at the picture, there's some areas here that you can see where you would lose the tension when you were torquing up. So if you're torquing up a bolt to 20 Newton meters, you would lose 10% at the small clearance there, and you would like maybe lose another percentage on top on the head of the nut. So these are all the things when you're using mechanical locking devices that will not help, but they will move towards the fasteners failing in the real life scenario. So here we have some of the traditional thread locking methods. When people ask me what are the LOCTITE competitors in the market, I always say that are these guys. So we have spring washers, cast-on nut, star washer, nut with a nylon insert or double nut. So all these, they are what we call physical locking devices. So they are the traditional methods that we've been using for a long time. And that's how some people still torque bolts and nuts together. And what's the problem when you use these sort of mechanical locking devices that we call? The problem is they are made out of metal, most of them, including the one that is made out of nylon. It's just the nylon insert, but outside is metal. So metal will have the same problem that we were talking before for the bolts and nuts. A lot of vibration. That metal is going to vibrate with the rest of the metal, and that's going to start like helping to come undone. Another problem that you have there is easy to corrode because it's made out of metal. It's not filling any gaps. So if it's a corrosive environment, that's going to attack the same thing as the structure from the bolt and nut would attack. It doesn't seal the thread. As I said, you have gaps inside the thread, so that's not going to seal the thread. It's just going to help. It's not going to protect against corrosion. It's just helping to hold the bolt and nut in place, but it's not helping to protect against corrosion. Also, a big issue is the stock that you need to maintain for your spring washers or for your normal locking devices, because it all depends on which size bolt you're using. You're going to need a different washer. So your stock control will be like way harder than using liquid thread lockers. So that's where we difference the traditional methods to the LOCTITE anaerobic technology. So everything that we see in the red bottles or in the white tubes with the LOCTITE name, we are talking about anaerobic products. So how does the anaerobic products work? The anaerobic resin works with absence of air and presence of metal. So which means that if we have a drop of LOCTITE on top of the table, it would stay there like wet for, I would say, for a long time, basically forever. The LOCTITE product only works when you have a presence of metal and when you exclude the air. And where is the best scenario that happens? Always in a bolt and nut. When you have the bolt and nut together, the threads, they touch each other and then they exclude the air there. Now you have absence of air, presence of metal, the liquid, the LOCTITE, will turn into a thermoset plastic, which is a really hard resin. So that resin will fill the gaps and will lock the device. If we look here on the next slide, in a perfect situation, we would have a bolt and nut like this one, where only 15% of the threads, they have contact metal to metal. The 85% that you have from the thread would be just gaps, as we can see here. So these gaps in a mining environment where you have sometimes rain, sometimes dust, you have some chemicals in the air, whatever you have in the air, even moisture or it's just dry, that would create some corrosion. If you create some corrosion there, you might end up having two different problems. The first one, you can get the fasteners to seize there, and then if you need to get any maintenance and done, you're going to have to chop them off and then replace them. And another one that you can get after a while, if the corrosion is there for too long, that's going to start damaging the thread and this bolt will just come unloose. So it won't hold together anymore. What the LOCTITE does, the anaerobic resin, it will fill these gaps that we can see, this 85% gap. And then we have absence of air, presence of metal. That's going to turn into that hard resin, the thermoset plastic, and that's going to hold the bolt and nut together and also will protect against corrosion. So that's the main difference between using just normal locking devices and using a liquid LOCTITE thread locker. The thread locker, yes, it will hold in place, same thing as the traditional method, but will also protect against corrosion, the inside of the threads, which is really important in the long-term run. With the LOCTITE products, when we talk about keeping the stock of the traditional methods, it's quite hard because you need different sizes and different shapes for each job that you're doing. With the LOCTITE products, we have three lines of thread lockers that we always discuss about it. We have low strength, we have medium strength, and we have high strength. All these products, they will handle vibration, the thermal cycling that we said before, and they will also protect against corrosion. The difference when you use one or you use another is the sort of job that you're doing. So let's say there is an equipment that you do the maintenance every week and there's not much vibration there. A low strength product would be the most recommended for this one. Why? Because it will protect against the vibration and the corrosion, but also when you need to get undone with hand tools, it's going to be really easily done. If it's something that there's more vibration there and you do the maintenance, but it's not quite so often, then we would recommend the use of a medium strength thread locker. The medium strength thread locker is going to be a little bit harder to get undone with hand tools, but you still can do with hand tools, but it's also going to do all the protection that we need. If you come across to an application where it's something that you need to stay there for as long as it can until the equipment fail, then we start looking at high strength products. So high strength products are products that's going to be not to say, it's going to be really hard, not to say impossible, to get them undone with hand tools. The only way that you can get them undone is with heat. So if you heat it up over 200 degrees, that plastic's going to melt and you can get them undone. But these are for applications where you don't require to do the maintenance quite often. That's why the color of these products are red. So every time that you're using, you see red, means like the traffic lights, stop and think that if you are using for the proper application. Other than that, you always end up using low or medium strength, because these are the ones that you can get undone with hand tools. Next one here, I'm just going to play a video. Andrew Foster, he's our application engineer in New Zealand, and he's going to talk a little bit more about the gap between the threads and how to apply our products.
Hi, I'm Andrew Foster. I've been with Henkel LOCTITE for 15 years. I look after the South Island of New Zealand. And today I'm going to talk to you about some Threadlocker basics. So, why would you use an anaerobic or a LOCTITE locking device? Well, it's pretty simple, and it's all to do with gap or airspace. So when you put a nut on a bolt, you only get limited metal-to-metal contact. And there's a couple of reasons why you only get limited metal-to-metal contact. One of the reasons are that obviously with a nut and a bolt, you have a big box of nuts and bolts. Every nut has to fit on every bolt. So they have to manufacture with a very wide range of tolerances. The other reason why there is a lot of gap in a nut and bolt is to do with imperfections in the metal. So there are lots of imperfections in the metal, and that prevents 100% metal-to-metal contact. In fact, you only get 20% metal-to-metal contact, there or thereabout, on a nut and bolt. So which means that you have a lot of airspace, and that's why you get a lot of movement. The issue there is, if you get a lot of movement, you get vibration, and that fastener can move, eventually it's going to work its way off, and you're going to get equipment failure. So there have been, over the years, many kinds of mechanical fastening devices developed. Probably the most familiar one would be the spring washer. So the idea of the spring washer, of course, is that it creates a bit of tension between the nut and the face of what you're actually doing up. And by doing this, it tries to add a bit of preload onto the nut to stop it coming undone. And some can say it does that somewhat. But of course, you still get a lot of vibration. The minute you get a bit of movement in that nut, it loses all its tension, then the nut comes off. The acceleration and failure becomes a lot faster. The other issue you get with the spring washer is that it can actually damage the surface of what you're bolting it up against. And the third issue you get is that it can corrode into place, causing you problems later on as well. So then, of course, people have come up with the nylock nut. So the idea of the nylock nut is a bit of plastic nylon in the top of the nut with the nut part actually underneath. So the idea is that when you actually wind it onto the bolt, that cuts a thread into the nylon or the plastic part and attempts to hold it in place and prevent it from rattling loose. The issue is you've still got your airspace or your gap in your nut side of things. So if you've got a gap there, it means that nut can actually move from side to side, and eventually it will actually work its way off. The only advantage you get with a nylock nut though is that it won't rattle completely off. The other issue you get with a nylock nut is when it comes to actually doing a nut up. So as you can see, I can only get the nylock nut only up, down as far as there. If I want to get it on any further, I have to wind it. And wind it, 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 and wind it. Until it's tight. If I'm doing up a fastener using a LOCTITE, all I have to do is simply wind it on by hand, only tightening up when it gets the last few turns to provide the torque onto it, or torquing it up to the correct torque setting. So it is very, very easy. So LOCTITE, it locks in place, it seals against corrosion, and it also helps with applying the fastener into place as well. It makes it very easy to actually put it down in place. That's all for today. Thank you for watching, and we'll catch up with you next time.
That was Andrew talking about. So why are traditional mechanic locking devices considered unreliable when frequently fail? So as Andrew explained it, and I said before, the problem is when you're using just the traditional method, you're not filling the gaps that you have between the threads. So that 85% air that you have there, if you're just using a normal locking device or insert nut, you're not going to be filling all that gap. And by not filling all that gap, you're going to create corrosion, it can be a big issue and cause that bolt to come undone or to damage the thread or get the fasteners seized there, which would be another nightmare to get them undone. With the LOCTITE products, again, if we look at the picture at the bottom, you can see that the resin will just fill up the gap and protect completely the system against corrosion or any impurities that you have in the environment. Here's just a machine that we have in the lab that does, I'll just go back on this one so we can see. It vibrates, like it's really high vibration, and it measures the loose of the clamp load that you have with products. So if we have a look here, we've done the test with the LOCTITE Threadlocker, and we're done with the normal spring washer. So if you look, the difference is they both start at the same point. LOCTITE drops a little bit, but then after it holds the bolt and nut in place for the whole time, while the one with the traditional fastener with the spring washer, it just holds for a little bit and then just drops and drops and drops and drops and just gets to the point where you can get the bolt and nut undone by hand. If we look at the graph here, we have a comparison between the LOCTITE products and some of the traditional methods that we have in the market, and we have also one that is just the bolt and nut. So if you look here at spring washer, it's really close to what is just a bolt and nut itself without any locking device. They are just a little bit better. While the LOCTITE product, if you look at the top there, the red line, you will see that there's that initial drop, but then it holds the bolt and nut together for way longer than until preventing any failure or any major problem that you might have in the long-term run. Now we spoke about corrosion and protection and filling those gaps and protecting corrosion. Mark, our application engineer in Western Australia, he did this test where we're going to be able to see the difference about just a bolt and nut with no protection and a bolt and nut with LOCTITE, how these bolts behave in a really corrosive environment.
Hi, my name's Mark Cassotti from Henkel, Australia. In this video, I wanted to run a quick experiment to see if I can show you how LOCTITE Threadlockers not only prevent fasteners from coming loose, but they can also protect the critical threads from corrosion damage. Most people know that LOCTITE Threadlockers are used to prevent nuts and bolts from loosening under vibration. What many people don't know is that because the anaerobic Threadlockers start off as a liquid and then cure to form a thermoplastic solid, they can fill the minute gaps between the threads of a fastener. This means we get 100% contact and we get a 100% seal. So what you'll see next is 2 nut and bolt assemblies left in salt water with a very low current being passed through the water for around 4 hours. After that, the current was shut off. I left the bolt standing in the water for another 5 days. So let's roll that now and we can have a look at the process. One assembly is a fairly standard dual lock nut assembly, and the other is the same setup but with a couple of drops of LOCTITE 243 added. So here you can see the time lapse of how quickly the current passing through the water causes the bolts to oxidise and erode. Some, if not most people, may be aware that even on a fully tensioned fastener, that there's only around 15% metal-to-metal contact. The point of this is really to see if that we can visualise the ingress of the salt water into the air gap between the nut and the bolt. So next, you can see the bolts being removed from the saltwater solution after another 5 days of being left to stand. Now you'll see the assemblies being taken apart. Right away you can see that it takes more effort to remove the nut that has the LOCTITE 243 applied, which demonstrates the products have retained its thread locking capability. But you can also see the cured 243 being crushed as I continue to undo the nut. Now, let's take a look at each of the samples closely. Firstly, we'll look at the plain nut and bolt assembly. The first thing that's obvious is that the threads of the bolt are wet. This is a pretty clear indication that the salt water had made its way between the threads and is now in contact with a critical area that's providing load to keep the fastener tension. Looking a little closer, we can already see the corrosion on the tips of the threads. Given a bit more time, some exposure to oxygen and changes in temperatures, the threads will continue to corrode and eventually seize this fastener, meaning removing it's going to be pretty difficult with normal hand tools. Next, we'll look at the sample that had the LOCTITE 243 applied to it. Considering the considerable force it took to break the nut loose, we can be certain that the salt water or the electrolysis process hasn't had any effect over the performance of the Threadlocker. Now, while the residue you see on the thread may not look great, that is the remaining adhesive that's been crushed and ground up as we remove the nut. That layer of thermoset plastic had filled the 85% air gap during assembly and bonded to the surface of the metal, creating a seal to prevent any of the water making contact with the critical parts of the thread. In reality, all I'd really need to do now is clean up this bolt with a wire brush and it'd be ready to use again if needed. I hope this has helped everyone understand the added benefits of using LOCTITE thread lockers in applications where corrosion and bolt seizure could be a problem, and thank you very much for watching.
So there was a video just showing how important it is to protect against corrosion. Of course, again, like the same video, that's an extreme situation, but in the long-term run, that's what you're going to see in the industry. We know that especially in mine sites, you're going to have different humidity in the air, plus you're going to have the presence of chemicals, so corrosion is a big issue for them. So protecting against corrosion, it's very important. Now just talking about like how to apply the LOCTITE products. In both videos, we saw them applying the LOCTITE products just along the threads, like we can see in the first picture. That's the most common way of applying the LOCTITE. What not many people know is that we also have a product that is a pre-assembled application one. So you would have the bolt and nut together, you would put a few drops of the product on top of the surface, and that product would wick its way in, filling all the gaps and locking the device. This one is a really good product for areas where it's quite hard for people to apply the LOCTITE prior to torquing up the bolt and nut. And I also like to say that this one is an emergency product that you have. In case that you assemble the equipment together and you don't remember if you put LOCTITE in that bolt and nut, you can just put quite a few drops of this one on top, and you will have the LOCTITE action working in there. So that's a really good product that not many people are aware that we have. On the next video, we're going to have Trevor, our application engineer from Brisbane, and he's going to be talking about how come he used the LOCTITE 290, which is the wicking agent one, to seal some gaps, like tiny little small gaps that he had in oil drums.
Hi there, my name's Trevor Holsall and I'm a LOCTITE application engineer for LOCTITE Australia, and I'd like to talk to you today about one of my case histories involving LOCTITE 290 wicking grade thread locker as a sealer. So let's get into this one and I'll explain a little bit further. So LOCTITE 290 is a different type of thread locker, whereas our normal thread lockers like 243, 263 that you may be familiar with, they're a pre-applied LOCTITE thread locker, so you put them on the bolt and then you assemble and tighten the assembly. With LOCTITE 290, because it works like a penetrating oil, you can apply it after you've put the nuts and bolts together and tightened everything up. So essentially, if you've got an assembly with lots of bolts, if you were to use a pre-applied LOCTITE like 243 for example, you may not get round to tighten up all the bolts before the LOCTITE 243 has started to cure. So in that situation, you can tighten all the bolts down, then apply some LOCTITE 290 to the outside of each bolt, and because of its capillary actions, it works like a penetrating oil. It will work its way into the spaces between the threads between the nut and the bolt, fully cure and act like a thread locker like 243 or 263 once it's all fully cured. But because of this wicking property, or penetrating property, it's also useful for other applications. And as an example, we've got customers who use it to fix problems with porosity in castings, for example, where you may have some porosity in an aluminium casting, and by applying some LOCTITE 290 to the area, it soaks into the porosity, cures, and then seals up the porosity and solves the problem. So in this case, taking that one step further, I decided to use LOCTITE 290 to try and help resolve this leak issue for this customer on these drums. So essentially, he buys these 200 litre drums, brand new from overseas, and what he found was about 1 in 10 was actually leaking. And because he's in the waste oil recycling business, obviously you can't send one of these drums out to a customer because it's going to leak oil all over the customer's floor, which is not a good look. So he's kind of stuck with all of these faulty drums, which were not cost effective to send back to the manufacturer for warranty because of the shipping costs. So he's kind of had this big stockpile out the back that had cost him a lot of money, and he couldn't really do anything with it. So what we did was we grabbed a couple of the drums, and because they had already been pre-tested, they obviously had a mark where they found the leak. So we put some LOCTITE 290 in the groove along where the leak was in the bottom of the drum, let it cure overnight for 24 hours, and then retested the drums, and it worked, and the problem solved. So now he could turn all those faulty drums into usable drums now that are out in circulation, and one happy customer. In this case, as a thread locker, using it as a sealer to solve a problem. Thanks for watching. Bye.
So the main thing about this video was just to show that even in tiny small gaps that we cannot even see properly, we can use the LOCTITE 290 because of this property of the product. And just to summarize everything that we discussed during this webinar and all the videos that we watched. So these are the benefits of using the LOCTITE Threadlockers. So first of all, you're going to increase the reliability. So you know that we're going to work more on that predictive side of the maintenance work. We're not going to be working so much on the corrective one. And we saw in the first slide what's the impact that's going to have in our costs. Another thing would be outperform the normal locking devices. So as we said before in every single video, we are not only locking the bolt and nut together, we are locking, protect against corrosion, and also promoting a little bit of lubricity as well. That's going to increase the work life of the equipment. So knowing that that bolt and nut will hold together for a while, we know when we're going to need to stop to do the maintenance. Again, it's going to protect against corrosion and save the cost for the company, as you're going to have less downtime. It's going to minimize the cost with stock and inventory. So as I said, different size of spring washers that you need for different size of bolts, while with the LOCTITE, it's low, medium, and high strength. It depends which job you're doing. That's the one that you're going to use. It's going to allow you disassembly. When we saw Mark's video talking about corrosion, even though the bolt didn't look as the best with the white powder on top, if you remove that white powder, the threads will be undamaged and you can reuse it, something that you cannot do just by using the normal devices. And also there's an excellent chemical resistance. So as I said, in most of the mine sites, some areas of the process, the environment is quite, there's quite a lot of chemicals in the air, and that can cause some chemical corrosion. While with the normal devices, you would have a problem, and with the LOCTITE products, you would have a protection. So basically, what we spoke here today and all the videos that we saw, it's a basic version of the LOCTITE training that we offer to our customers. So LOCTITE has strategically application engineers positioning within Australia, and what we do is we go to the customer and we deliver this training session to the maintenance crew. So they know where they need to act and which sort of products they need to use for different issues that they have on site. The way that we do this, we always like to break this into steps. So you're going to send an inquiry, the designated application engineer will contact you, and the first thing that we will do is a plant inspection or a plant survey. This one, we're going to walk around with the person in charge, and we're going to have a look in which issues you have. So we're going to have a look at the issues that you know that you have, and there's something that comes from our experience. We're also going to say, look, this one here, you could improve by using this solution. Once we do this plant survey, we're going to put together all the solutions that we have within the LOCTITE range. By doing this, we're going to deliver the training. But just bear in mind that the training that we deliver, it's not a training where we just walk there and talk about LOCTITE products and applications that I've done in Brazil 10 years ago. We go there and we talk about the applications that we got from the plant survey. So the training is designed for each customer that we go and talk. So we're going to be talking about our products, yes, but we're going to be talking about real life situations. That's the main thing about the LOCTITE training. It's not us going there and just talking about the LOCTITE products. It's us going there and sharing experience with the customer in order to get what are the issues and use our experience to find the proper solution. Once this whole process is done, after 2 or 3 months, we just come back and we redo the plant survey. And by redoing the plant survey, we see if our solutions help them out with the issue or if there's something else that we need to work on it to get it better. But that's the whole idea. The whole idea of the training session, it's not only teaching people about LOCTITE, but it's just be closer to them and then get them working really well with us. This way we can offer solutions that would benefit them in the production line or in the mine site. If you would like to know more about our training sessions, please just send an email to loctite.inquiries@henkel.com. This one will be forwarded to the application engineer in your region. They will contact you and they will follow those steps of the plant survey, designing the training, as I said before. And that's all from me. Thank you very much. Thanks for your time. And if you have any questions, please, I'm happy to answer them.
Thank you so much, Carlos. So yes, please, we encourage everyone that has a question to put it in the Q&A box. We actually have a few questions coming through now. So we'll start with at the first question that came through from Jeff Jared. He asked, Carlos, what is the curing time for each type?
It will depend. So mostly full curing time would be within 24 hours. But some of the products they have, or the working time that we call, they might vary. So the LOCTITE 243, it's around 10 minutes, but we have some products that will be around 20 minutes. That will depend. Fully cured, I would say 24 hours, but just the initial curing time, the working time that we call, the time that you have to do any adjustment, this will depend from which product you're using. But we'll be within 30 minutes, I would say, most of our products.
Okay, perfect. And then Jeff's asked a second question on what is the projected loss in preload when vibration and settlement is present?
That also will depend on the friction, which material you're using. But in tests that we do with normal spring washers, I would say that spring washer, you torque it up to 20 Newton meters. When you try to get them undone, it's going to be around 9 to 10 Newton meters. So you lose roughly, I would say, 50% of the torque load there on those bolts and nuts. While with the LOCTITE, you won't lose. And in some cases, if you're using the high strength products, you would even gain more torque on that bolt and nut.
Great, thank you for that. This third question is from Anonymous. What is the coefficient of friction when using LOCTITE 243, for example, in regards to determine bolt tightening torque?
That's something that needs to be discussed with the engineer because, again, it's going to change according to which material you're using. So the engineer will have to calculate what we call the K factor, which is the lubricity factor, and then you're going to be able to find out what's the coefficient.
Okay, great. Perfect. The next question we had are there any Threadlocker products that could be used for stainless or plated bolts? A couple of people have upvoted this question.
Yep, yeah, definitely. So by using the primer, we have the primer, the 7471, which is copper salt zinc acetone. You spray on top of the surface. You're going to convert that surface from what we call inactive metal to an active metal, and then you would be able to use any of our LOCTITE products.
Okay, perfect. The next question is from Jeff again. Have you compared LOCTITE against other locking methods other than the ones mentioned in the presentation against vibration?
So usually when we deliver the training, we do against spring washer and the nylon insert nuts, but we are happy to do any test if it's required for Jeff. He can just contact us, and we are happy to just to test the LOCTITE against any other LOCTITE device that he's curious about it.
Great, perfect. Another question from Stefano. Can you use expired LOCTITE?
No, it's not recommended. So the shelf life, it's around 24 months. Always at the bottom, you will find the expiring date of the product, and we do not recommend that you use any of our products when it's expired. Like coming from the R&D side of the business, I can guarantee to you that the product has a life expectations because we know that the product will work. After that, we cannot guarantee that you can use the product.
Okay, perfect. Next question that's coming from an anonymous attendee. Can you reuse the same nut after having LOCTITE applied? Is there a limitation for the high strength grades which doesn't allow the bolt and nut to be reused?
No, so in most cases you can reuse, like we saw in Mark's video. There's a little bit of resin that stays on top of the surface. As long as you remove that with a wire brush and you clean really well, and the threads are still as per normal, you can reuse the bolts and nuts after you applying LOCTITE.
Excellent, thank you for that. I think you might have answered the next question, which was on if you're removing certain bolts on a regular basis between LOCTITE applications, is there any need to clean or prime the bolts and or nuts?
Yes, cleaning surface preparation is the key for any LOCTITE application. So once you remove, you need to clean really well and then reapply the primer there and then use the LOCTITE product on top of again.
Okay, great. Let's see, is there anyone else that has any other questions? Or some good ones that were brought up. Any other questions for Carlos? Okay. Well, we'll end there. If you obviously want to reach out to Carlos, he's got his details right here on the holding slide. You can contact them at loctite.inquiries@henkel.com, and there's also a tech hotline. We will be posting this video on our YouTube channel, so you can watch it on demand. So as well, if you want to review any of the points that Carlos has mentioned and still have inquiries, you can reach out there as well. But thank you so much, Carlos. We really loved having you on here, and it was a very great presentation.
Thank you very much. Thanks for the opportunity.
Thank you.